If you guys are hearing that, stop welding. Stop what you're doing. Check it out, guys. Today we're going to be talking about undercut, the discontinuity, the defect located at the weld toe. You know, the edge of your weld, here, 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 here. No matter what joint configuration that you're doing, you can get undercut at the edge of a weld. What is undercut exactly? Well, basically the base metal has just been melted away right at the edge of your weld, and it's not properly filled in. So what you're left with is just a sharp, jagged edge along the weld toe. This could cause a lot of stress risers in those welds, weakening the structural integrity. It makes it susceptible to cracking and corrosion. Basically, if there's a crack, there's more water that can get in the crack and causing failures, right? We want to try to avoid it, or at least have as minimum as possible when doing any type of welding. Today we're going to be talking about the gas metal arc welding process in particular. That's MIG. Today what we're going to cover is material thickness, wires, feed, speed, and voltage. Those three things are pretty much the first three things you need to try to tackle in order to try to nip that undercut in the butt. But if that's not working, it might be a little bit more technical than just changing some knobs. We might have to consider what transfer mode we're using, what gas mixture we need to be using for that transfer mode, and of course the joint design and what techniques we should be using. There's a ton of different ways to get undercut, and that's what we're going to cover today. As you all know, with gas metal arc welding, you need gas, and I am fresh out. Now, I think some of y'all have seen the back side of my shop, and this is where I keep most of my gas bottles. I don't use this little bottle much. This is one of your 100s, your 125 size bottles. This is for your tri-mix gas right here. At least this bottle is. And I'm definitely not going to be using that today. We're not going to be working on any type of stainless steel. We're going to keep it basically to carbon steel. And as you know, 75-25, which is this bottle, is most people's gas of choice. Now, that being said, you all have pointed out to me that I'm not utilizing the proper shielding gas for spray transfer. And being that we're going to be using some spray transfer today, it's only fair to you guys that I go get the right gas along with a fresh bottle of 75-25. And you guys are going to get to see probably one of my least favorite / most favorite parts of welding, which is new gas day. Such a pain in the butt getting these bottles loaded up as an individual. I guess as my entire career, they've always been a pain in the butt to load, especially if you're just a one-man show. Now, loading your bottle is no easy task, especially in a lifted truck, so if you need a buddy, by all means, get a buddy. Just lean it up, lift with your legs, push into it, keep it against that bed, and it makes a big bottle fairly light if you use a little bit of leverage. I weigh about as much as that bottle when it's full, and I get it up there no problem. Now, I'm sure everyone's got their own way of securing a bottle. No one's ever taught me how to do it. This is just how I've always done it. Hook it up on the truck bed right here, come underneath it, not over top of it, and make one loop around that neck. And then you're gonna come up, and it's gotta be able to jump around the bottle here and come underneath it one more time before it comes over top to this hook here. Usually push it up against the wheel well pretty good. Pull all that slack out of it. Don't mind my posing. Once it gets up against that wheel well, man, you can start torquing down on it. That ain't going nowhere. Make sure you wear your steelies on bottle day. Now, typically speaking, if you only have like a 125 or a 200 size bottle, those are owner bottles. You go in and you can still get them exchanged just like you can a 300, but being that I have 300s, you're gonna wanna have an account set up. But it's still pretty easy. They make it really simple here at Airgas. Just walk inside. They got everything you need inside that store, so while you're getting gas, you can grab whatever else you need. Talk to the sales associate at the front. They're gonna come outside, see what you got, double check, make sure it's a good looking bottle, and then we're gonna go around, swap out the bottles, get a new one in, and then you're on your way. Whew. It's getting freaking hot out here in Texas, man. I'm gonna show you guys the anti-Canadian tuxedo, and that's the South Kansas khaki. Now you might think, hey Austin, this looks a bit excessive. You got, my friend. I did this all for you guys. I hope you understand that. This is all done for you. I went to go get the new 75-25 bottle here. This is that regular industrial size bottle. And then we've got these fancy Arcal bottles here. These are all different ones. You might think to yourself, Austin, dude, they got you. These are all rental. They're all rental. I can use them as long as I want and return them when I want. I'm gonna show you guys today's lineup because I wanna do it right for y'all. From the right kind of gas for your hardwire short circuit MIG, even up into spray, to even another alternative spray gas. Even just the same stuff, 75-25, but just better quality. Now, like I'd mentioned, this is probably my least favorite day and the best day. It's tedious, it takes like half your day. You've got to pick up heavy stuff, move stuff, and by the time you get home, you finally got gas. There is a lot of benefits to these Arcal bottles. One of those deals is just about the quality in the actual gas itself. What I can tell you is when it comes to trying to figure out essential variables in your welding process as a business owner, and you're sitting there trying to figure out, is the gas a problem or is this an issue? I'm not really sure. If you have something that can maintain a certain quality, then you're gonna realize, oh, hey, I know it's not the gas is good gas. Not only that, but you're gonna save a lot of time having to get all that stuff set up, unscrewed and screwed on, compared to one of these with everything already built in, and you just gotta put a quick connect in and you're ready to go. Now, I've pretty much just wrecked my shop when it came to prepping for this video. I wanted to work in all of the different transfer modes, so we needed different material thicknesses to do so. I grabbed some 3/16 plate. It was a little rusty, so I got the 3M fiber disc to make short work of it, get it cleaned up, ready to weld. We tacked that into a couple different joint configurations, like a lap joint, a T-joint, and an outside corner joint. Like I said, moving into different types of transfer modes, we have the Cyclone 263 PI here. It has all of those modes in it. Not only will it work in the short arc transfer mode as far as lower voltages, but it'll also get up to about 30 volts, which is pretty spicy and well in that spray transfer range. And just as you guys asked for it and told me before, I am not properly in the spray transfer because I don't have the right shielding gas. I heard you and I know it, and I had the resources now to go out and get it. We've got the Arcal Force gas here. This is gonna be 18% CO2 and 82% argon. It'll work in the short arc transfer mode, it'll work in the spray transfer mode, and the pulse mode that we're gonna be running this Cyclone 263 PI on today. We'll make sure the bottle is on. We got our CFH set on this back side to about 30. Knowing that we're going to be going into those higher transfers and higher voltages, we needed that other thicker plate. So I got the 3M Cubitron 3 cutoff wheels. Definitely wasn't short work of it, but everything was still nice, square, and clean, so that I got everything prepped and fit up on that 1/2-inch plate. Now we're going to start setting everything up for our first weld, which I've gone and already done. We've done a 19 volts, 230 on the inches per minute. It's a little bit cold for 3/16 inch plate, but it's still well within the short arc transfer. I just want to take a look at the weld real quick before we start messing with these parameters that we have set. Taking a look at my handiwork here, we did a straight push motion with our short circuit MIG, 19 volts, 230 on the inches per minute, 035 size wire. We've got the Arcal Force gas on it, and we started off with little to no manipulation, and I started doing a little bit more pattern towards the end. You got to be careful with the pattern that you can put in there because you might be underfilling some spots and thus cutting into some of that metal and leaving some undercut. If I just take my flashlight across the top here, you can see those uneven edges, the uneven toes. For me, I definitely want to see those lined out. If I don't have an edge of a plate to keep the undercut under control or the underfill under control, then I need to go off toes, those edges. Those need to be properly filled in and properly straight. So you can't get too carried away with those fancy circles or cursives or whatever it may be, because you might just leave a little hint of undercut. Now what we're gonna try to do is adjust some of the voltage. I'm gonna go to the machine and I'm gonna turn the voltage too high and make the same weld and see if we get any undercut. Now remember, all I've done is turn the voltage up. I didn't touch my wire feed speed at all, so we're at about 23 volts and 230 inches per minute. You can get undercut by not filling things in. So if you don't have enough wire, likely you might get some undercut. Oh, we love that sound, that real globby sound. Oh, it sounds awful. And if I adjust my travel speed going a little bit too fast, it definitely doesn't accompany this to be any better. Well, I'm just tired of listening to that. Do we have any undercut? A little touch when we started to increase that travel speed, but could be a lot worse. Let's increase that voltage a little bit more to 24 and drop down to 200 inches per minute. This ought to make a mess. So still even less wire, even more voltage. Trying to maintain a good proper travel speed, but if you guys are hearing that, so please stop welding. Stop what you're doing. And you can even see that little bit of undercut at the front edge of my arc. It's just that arc is cutting into the plate, and the filler metal, that puddle, isn't there to fill it in. Just moving too fast and not having enough wire feed is going to give me quite a bit of undercut. Get rid of some of this smoke. Definitely got undercut on the edge of it. Not as much as I thought we would get. We definitely got a lot more when we changed those parameters towards the end. It's one of those things that if your voltage is too high, it's probably pretty obvious. It's making a horrible sound, and we're cutting into that plate because we don't have enough filler metal to come in right behind it. So now we're gonna go down in the voltage and go up in the wire feed speed. Probably not likely gonna be a problem, it's just gonna be too cold. It's not gonna be undercut where it's melting metal, it's just gonna be too cold. Definitely is piling up. Gonna put one big weld on there, see if some of the gravity will take an effect too. Say if I want to make a big weld and I go against this big fillet and I only position myself pointing down, make for a pretty gnarly weld too, or get some undercut on the top if you don't have the right gun angle. Pretty crunchy sounding, a little cold looking, like we have a lot of voltage there because there's just not making enough heat to melt the metal before the wire comes in. Now looking at this freaking slug of a weld, you could tell at the beginning I started going on the bottom and then I decided to start making a bigger weld here. But it doesn't matter on the top or bottom toe. I don't see any undercut whatsoever. Even trying to carry a big weld, that gravity can really play a big role in it. Even with a cold weld, I don't think that too much wire is going to be your problem. Not enough? Most certainly. The next thing we're going to talk about is material thickness. I've got some 3/16 plate. There's a limit to how much heat that it can handle. How do you get undercut? Add more heat, just as we did with the voltage. If we're going to do the same thing on this lap joint here, we're just going to go straight into spray transfer, okay? We don't need to be into spray transfer when it comes to this material thickness. We're going to get way up here towards 28 volts and let's say like 480. Like not too much voltage and not too much wire feed speed. They're both balanced, but our material thickness isn't enough to handle all those beans. That's a good recipe for undercut. It's like almost there on that spray transfer side of stuff, and I tried at the beginning to try to get undercut by changing like the gun angle a little bit, again not favoring both sides evenly, trying to chew up some. I got a little bit of undercut, but not as much as I thought. Then towards the end I didn't really try to get much, but we still got a little bit of undercut. I'm gonna still try to go up in voltage a little bit more. Let's try all the way up into 23 volts here. Let's get all the way up on them inches per minute. Well, not all the way up, but 30. Now we're really working in that spray transfer, at least we should be. Not only that, but we flipped this plate up so that we're kind of working at somewhat of an angle. So maybe that's going to pose some more problems for us. We'll see. I definitely am seeing some undercut on that other plate. Definitely starting to be too hot of voltage and amperage for this thickness of plate for sure. Ooh, definitely ripped away some metal. Put a lot in too. I definitely think the position and the increase in all those settings definitely had something to do with it. I didn't get much undercut, if any at all, on this top plate, but I definitely pulled back and melted this bottom plate a little bit too much. And I bet we have a crazy amount of penetration on here. Still, that gas seems to be doing all right. It doesn't exactly sound like spray transfer that I'm used to. I think we'll see some of the different results if we try that other gas when we switch to it. But the first thing that we got to do when we notice undercut on thinner material is go down in voltage and wire feed, or we may need to be working on some thicker metals, right? So now we're going to try to run some beads on this 1/2 inch plate and see if we can't make it look good with what we got. All right, let's give a run on this first joint right here, T-joint. Oh man, I definitely need to turn up my wire feed now. I turned it too far down. That's just what we're just having the same result there as we did earlier. I'm going to turn it back up a little bit to around 400, because right now I'm trying to make a weld right here, but got a lot of material to fill in still. That's a little bit better. Still getting that undercut, you know. What can we change if I don't want to change my wire feed speed or my voltage? Well, just make the wire thicker. So we're sitting here with a weld with undercut, but we don't want to change any of the parameters. So we just need thicker wire. If that's all that's needed, that's all that's needed. That's all we're going to do. Do your boss man a favor and just go ahead and clip it at the end of the gun and roll that wire back on your spool instead of sitting there and cutting it and leaving it in your MIG gun, or leaving that you have to yank out of your MIG gun. I'm going to switch over to the 045 size wire, a little thicker one. Adjust these drive rolls. And now for probably one of my favorite parts of this machine. I don't know why it took so long for machines to have this. That is the wire feed, automatic wire feed with the easy feed. You could turn the easy feed off and it'll go a lot faster, but if you just want it to go nice and easy, hit that easy feed and it runs it out the end of your gun. While it's easy feeding me, I'm gonna go ahead and put on my other neck for this Abacore Benzo gun, this Abby MIG gun, because I want 045 size consumables along with the 045 wire that we just put in it. One other thing I really like about this gun is that we can obviously manipulate it too, so that we can make sure we have the appropriate gun angle, because a travel angle or gun angle, work angle, either one of them can lead to some undercut when you start moving into different types of processes like spray or pulse. We have sized up the wire and changed nothing from that first weld that we got with this skosh of undercut all the way across. We're going to run 2 beads. I'm going to use this flex neck for this 2F weld to really get a nice flat gun angle for this first bead. Wow, that's freaking crazy. A lot of metal is being deposited now that I've gone up in that wire size. I can just see that arc stabbing into this 1/2-inch plate. Still pretty smooth. I'm going to see if I can change the gun angle here on this Abby MIG gun, this gooseneck, what I like to call it. Get this top bead. Stay with the push angle. Try to make sure it fills in. I still think I got a skosh of undercut because it's hard to do it in even a 2F position. Without a freaking doubt, we are depositing a lot more metal into this weld joint, but even working at those hotter amperages or hotter voltage, hotter amps too, with the wire going up, I'm just stabbing into it, man. So for this position, for this 2F weld, you can still see that shadow undercut all the way across. It's not like aggressively sharp, but it most certainly is cut into the metal. And at that crater, oh my goodness, that crater is the definition of undercut all the way. We're gonna try the same thing, but we're gonna try to work it maybe in a flat position and see if we have some better success. That looks a little bit better, I'd say. So obviously I think working on things flat with the spray arc definitely eliminated a lot of that undercut. I could probably favor one side because it just seems like it's just a little bit of something. And obviously we don't have a crater issue compared to the other side. But now what happens when we take that gas and change it to a really sprayed transfer gas? Alright, now all we've done is just simply swapped out that gas. I'm going to purge that line a little bit, make sure nothing's in the machine. So we got some of that Arcal speed gas put in here. Let's see if that changes anything.
I've gone ahead and thrown up some stats of these two gases because I thought originally that the higher argon content of the speed would make this weld a little hotter.
You can even hear it a little bit more. Here's some of those spray characteristics. I definitely got some undercut against that top plate. I know that metal is hot, but we're going to double up anyway. The only thing we're going to change now is travel speed.
Now come to find out, this gas is actually a lower energy gas. It just feels hotter because it takes less amps and volts to ionize to make that spray transfer happen.
I think I went a little bit faster, a little bit closer as well. Whoa! There you get something set on the front of that machine a little bit better for the start of that puddle. Good golly, I'm definitely cutting into that top plate now. That's not the trick. Definitely seems to be a little bit warmer. I don't know what I did at the beginning of that. We got to set some of that upslope or downslope for the start of this machine.
Knowing all that now, I should have definitely turned down some settings to avoid this bit of undercut that I've got.
But overall, these Arcal gases are seeming to work good. You could tell the Force has a different sound, a similar sound throughout the transfer modes. And if you put into that speed, you definitely hear a lot more of that spray transfer in there. Now I'm going to switch over to Pulse. and play around with it a little bit and see if we can get some undercut with that. All right, we're at 200 amps right now with the Synergic pulse. I'm gonna get off of the speed gas and I'm gonna hook back up that force gas, turn it back on, get a little bit more CFH, closer to 35. Now in my experience with pulse, the best way to get undercut is by really messing with your angle. We got a really severe push right now, and then if you go to a really severe drag, is typically where I see a lot more undercut and misshapen bead with a pulse MIG transfer. You really want to just be straight in that sucker, straight in, or a bit of a push for sure. It honestly doesn't look too great for us when it comes to that undercut, man. I'm just having a hard time at those higher amperages in this 2F position, and I'm just getting that undercut like crazy. I'm gonna try to turn things down and see if that'll help. All right, with things turned down, let's see if that helped manage anything. So I'm definitely trying to learn some of this Synergic pulse a little bit better. This is the first time I've had a pulse MIG machine in like a decade. It's not something that you set typically like a normal short circuit MIG when you're setting your wire feed speed. This is Synergic, so you set your amperage, whereas normally you would set your voltage. Now that we gotta set our amperage, it's gonna give us a voltage as soon as we strike an arc because it's Synergic and it's reading all that goodness, but it also needs that arc trim, which is kind of your contact tip to work distance, and it can actually control that variable. I do believe that variable will also give you undercut if you don't use it correctly. I hope you guys took some value out of watching this episode. I know I did, and I got a mess to clean up, I can tell you that. See you guys on the next weld. Check it out today. Check it out, guys. Today we're going to be talking about undercut. Now don't mind my whiteboard. I know it's a little bit dirty. I can't spell worth a dang, so I had a lot of erasing to do. Today we're going to be talking about the gas metal arc welding process in particular. Try to get it around that way.